Hello, my name is Gary Millett. This is the fourth of four topics that are in the Internet of Things introduction section. Um, this is titled Cloud, Fog, and Mist Computing in the IoT, how they are related. And so let's begin. On this slide, you see the classic closed loop control system down below. And in another presentation, we illustrated how the typical control system has evolved by the addition of communication interfaces to our digital-based control systems. So what does this do? This allows us to implement IoT applications. A networking connection to the cloud or some other more local, i.e. fog or mist computing entity. With these network interfaces, we can now create cyber-physical control systems that are enabled by the internet. So again, this classic control system here, the only thing, there are blocks for a DAC and blocks for an ADC. Today it tends to be that the digital controller contains the DAC inside of it, and the sensors also contain A to D converters. So maybe we want to delete those blocks. Nevertheless, what we're really interested in is that the controller on the far left, there's an interface, and it's got a double-ended arrow there, which indicates data can go in or go out. So before we go much further with this, let's take a look at what Cisco has for a view of IoT networking topology. So here's a diagram from Cisco, and this comes from their Internet of Things course, Things and Connections. And it turns out that there's 4 layers shown here, and the bottom layer are the devices. So the device layer, remember, it's like the physical layer of the OSI 7-layer model. You might see a toaster there, looks like a vacuum cleaner, some type of blender, a camera, a tire for a car, a light bulb, and so on, various things that are connected from the device layer. It says sensors and devices next to it there. And they are connected to controllers. And the controllers, well, Cisco talks about the edge and the fog layer as being the controller layer. So edge is a term we'll talk about a little bit more, but let's just say fog at the present time. And the next layer up is the network layer, routers. So the controllers are connected through routers to the cloud, the internet cloud that's shown between the top 2 layers. And what happens is the cloud, the internet delivers to the cloud layer data, and that goes to data centers, and that's for processing computers as shown up in that layer. Now, again, when the cloud first came in, that's where all the computing was going to be done, but as we just mentioned, it turns out that devices and sensors produce all kinds of data, and we would overwhelm the cloud at this point with that data if everything got done in the cloud. So we'll talk more about that in a couple of seconds. So what do we mean by cloud, fog, and mist computing terminology? Well, these are terms that are used to describe the relative nearness to the actual physical system being controlled. You could think of cloud way up in the air, fog tends to be close to the ground, and mist is a form of fog, but it's much less dense. So fog can be very dense, mist is not as dense. We'll talk about how that ravels out. So cloud computing is the delivery of on-demand computing services from applications to storage and processing power, typically over the internet, mostly IT in nature. Again, we've said that before. And IBM, Google, all these people, Amazon, allow, or rather offer cloud services at this point in time. You can store your pictures on the cloud. You can actually have, cloud computing services if you want. What do we mean by fog? Well, fog computing is the concept of a network infrastructure that stretches from the outer edges of where data is created to where it will eventually be stored. So mist computing is the extreme edge of a network, and by that we mean closest to the physical system. So, I might have a sensor, and the sensor might have an embedded microcontroller with it. So again, the mist computing typically consists of microcontrollers and sensors. Mist computing uses microcomputers and microcontrollers to feed into fog computing nodes and potentially onwards towards the centralized cloud computing services. So there are 3 short videos that talk about fog and mist computing, and they're relatively short, 5 minutes. You should watch these 3 videos. They're all YouTube videos. So a question might be, what is edge computing? Well, another term commonly used to describe mist or fog computing is edge computing. Of course, the problem with using the term edge computing is that it tends to be used to describe both fog and mist computing. It's therefore ambiguous and hence confusing. The metaphorical terms for cloud, fog, and mist are much more indicative of processing power. That is, fog is much denser than mist, hence fog computing has more processing power than mist computing. This may blur, and pun not intended, in time as microprocessors become more powerful and inexpensive. Now, another reference model is from the World Forum, the IoT World IoT Forum, and here you see 7 levels. People are kind of stuck with this from the 7-layer OSI model, and they like to put things into nice, boxes. So you see level 7, collaboration and process, people and business processes. Layer 6, application, reporting, analytic, control. Layer 5 is data abstraction, aggregation and access. Layer 4 is data accumulation or storage. Layer 3 is fog or computing, or edge computing they call it here. Data element analysis and transportation. Layer 2 is connectivity, communications and processing units. And layer 1, physical devices and controller, the things in IoT. So thinking about cloud, fog, and mist planes, we see that the cloud is where IoT reference levels 5 through 7 tend to take place, and they tend to be IT in nature, non-real-time, as shown here, query-based, while IoT reference levels 1 through 4 tend to take place at the fog layer, which is layer 3, and mist planes, layer 1, and are more OT in nature. So they're real-time, operational technology, and event-based. You can see that in the World Forum reference model. Again, top 3 layers, query-based, non-real-time, IT. Bottom 4 layers, event-based, real-time, OT. Here's another view of the same thing we just talked about, with a little bit of symbols in the picture. So again, key points: IT and OT, decoupling, scalability, agility, interoperability, legacy compatibility, analytics, integrated with the enterprise. So again, the same. This is the IoT World Forum again, and you see the data center at the very top. Application, reporting, analytics, so you see all kinds of dashboards there and graphs and so forth in the analytics. Data abstraction. Data abstraction is the aggregation and access, looking at data and abstracting information from it. Data accumulation, you see storage there, a bunch of disk drives. Edge computing, I don't know what those symbols are there. Data element analysis and transformation. Connectivity shows things like routers and switches and so forth, communications and processing units, and then of course the physical devices. At the edge we have sensors, devices, machines, intelligence edge nodes of all types. So again, that's a nicer visual description of what we just saw in the prior slide. So Cisco again takes a look here at IoT network architectures, and they define a few things. Here's a device to device. You see that if one device wants to talk to another device, what happens is the device layer, and if we talk about the 7-layer OSI model, we always talk about things going up or down through those layers. Here they've got them going horizontally, not a big deal, but the device layer, you notice the top device has a double-ended arrow coming out of it, says dry earth sensor, and the bottom device is a watering system. So at that device layer, we have data acquisition and sensors and actuators. So data comes up from the dry earth sensor, goes through the network, and gets transferred back over to the watering system. So the network has data transmission and wireless and wired networking. Those would be the hardware ways that data would be transferred. So I guess what you'd say here is you have a dry earth sensor. If we discover that the earth is very dry and needs to be watered, well, what happens is we have some type of program running that allows the transmission of the on-off control to the watering system. So the dry earth sensor would probably have a MIST computing device in it. In this one, we're going to go device to cloud. So in this case, we notice on the far left, the device layer, we have a traffic volume sensor, and then we have a street light system. So again, device layer sensors and actuators, and more sensors and actuators. So what happens is the traffic volume sensors send through an IP network to a cloud layer data center. The cloud analytics servers for storage and computing. The cloud analytics send through an IP network back to the streetlight system. So again, the network layer is doing data transmission, and that's done either wirelessly or wired. And here the processing is done up at the data cloud or the cloud level with the data center. A few more layers here, a little more complicated. This is device to gateway to cloud. So what we have, again, at the device layer, we have a non-IP sensor. So we have data acquisition and sensors and actuators. We have an edge fog layer, prefer the fog designation. So that's a local gateway, a fog node, another local gateway down below it, a fog node. So edge analytics, protocol conversion, controllers and gateways. And then we have the same thing, the network layer of IP networks for data transmission, and they're either wired or wireless. Then we go up to the cloud layer again, which is cloud analytics. At the data center, we have servers for storage and computing. So in this case, the sensors are not able to take and deal with the data. They're just giving raw data to the local gateway, the fog node, which does some calculations, analytics, edge analytics, and then we transfer information up to the cloud. And lastly, here we have 5 layers. This is device to gateway to cloud to application. So now at the device layer, we have an IoT device with non-IP sensors. Again, data acquisition sensors and actuators. The edge fog layer is a local gateway. And again, edge analytics, protocol conversion, controllers and gateways. The network layer is the same as it was before. It would be routers again, switches, data transmission, again, wireless and wired. The cloud layer, in this case, passes data to an application layer. So the cloud analytics has servers for storage and computing, but in this case, there's a specific application, and that's done with an application server. So they call that application layer automation control. So a question might be, what skills do we need to deal with this technology? Well, we must be able to talk to the hardware. So the hardware is, microcontrollers and microprocessors. So we've got to be able to take and program them and then interface sensors and actuators to them. That is, deal with I/O, input-output. We need to be able to deal with operating systems, for instance, Windows, Linux, mostly dealing with file systems and basic commands, which allow us to send data to the cloud and request data from our installed Internet of Things. And we need to be able to connect our hardware to the Internet by either wired or wireless connections. What about cloud servers and IoT? In the cloud, we tend to have servers that deal with IoT applications. These servers would be known as application servers. Some wireless technologies used in the IoT realm use a different architecture to enable their operation. LoRa, for instance, requires a network server to facilitate the wireless network connection, and then employs an application server to enable a particular IoT application. The use of 2 servers is somewhat unique to LoRa and provides security to the IoT application.